Welcome back. Code Travel, Electronics 101, Common Collector Configuration Bipolar Junction Transistor. Characteristics: has a high input impedance, low output impedance, also called as emitter follower. The base terminal as an input, the emitter is the output, and the collector is common to both input base and the output side in the emitter and connected to the power supply. The voltage gain of the common collector is about 1 or unity, and the current gain is high. The input and the output phase relationship is 0 degrees. The circuit serves as a non-inverting amplifier. Applications: switching circuit, driving small load, impedance matching. Different formulas: current junction IE approximately equal to IC. IC is equal to beta, current gain multiplied by the base current. IE equals IC plus IB. The instantaneous voltage is equal to the peak voltage multiplied by sine omega t, and omega t is 2 pi times the frequency multiplied by the time. Common collector circuit diagram: we have a coupling capacitor in the input side and coupling capacitor at the output side. Our output is at the emitter and our input is at the base, and we have the voltage divider biasing resistor. The supply is 12 volt BCC NPN transistor, and the load is RE. DC analysis equivalent circuit of the common collector. Redraw the schematic using bipolar junction transistor model. Capacitors are considered open using Kirchhoff voltage law voltage divider, input impedance, and on this side is output. AC analysis: redraw the schematic diagram. Capacitors are considered short in AC and DC supply are connected to ground. The output impedance is in this side. Input impedance is on this side. By Thevenin's theorem, input impedance is equal to the parallel value of the two resistors and the inverse sum of beta RE and RE, while the output impedance is the parallel RE, internal resistance, and load RE. RE is much lesser than the load RE, so therefore our output impedance in this side is high, and it is equal to approximately equal to RE. The input and the output graph: the input and output phase relationship is 0. Moving to simulation, go. The coupling capacitor output at the emitter side, the input and base. Collector is common to both input signal and output signal. Voltage divider RB1 and RB2. DC analysis: capacitor is open circuit, so this one is excluded. Therefore, the voltage in this junction is equal to voltage divider of RB2 100 over the sum of RB1 plus RB2 multiplied by 12 volts. And it is roughly 1.1 volts base voltage. And the base current will derive by getting the value of the IE, and IE is equals IC. So to get the value of BE, the voltage is 1.1 minus the internal or the thermal voltage of the transistor, which is equal from the range of 200 millivolts to 500 millivolts. Let's say we have 500 millivolts. 1.1 minus 0.5 is equals 0.6, and then by Ohm's law, IE is equals 566.7 millivolts over 2000 is equals 280 microampere. IE equals 280 microampere is equal to IC. And then IC equals beta multiplied by IB, and then IB, which is 280 over 100, our beta is 100. Please look at here, our beta is 100, and then 280 microampere over 100, and then we have 2.8 microampere input current in the base, and our output is 565.7 millivolts. Okay, let's run again. The input, it is a zero-phase relationship between the input and the output, meaning to say the input and the output waveform is in phase. Common emitter is 180 out of phase, while the common collector is in phase with the input and output waveform. Transistor is at forward active, meaning to say circuit is amplifier. Let's change a little bit higher input, which is 5 volts. Notice that this one is 5 volt, this is 2.5 to the maximum from the zero level, and then output is 1.63 volts in this area. And then after this capacitor, so it is in phase with the input and the output. Now let's say stop and reset. Start from the origin. It starts from the origin also, and then our transistor is on the forward active. Let's say let's put a load and the output, a resistor in this side. The output is from the range of minus millivolts to 100 200 millivolts. Is in the forward active and it's on the cut off region, so meaning to say it's turn it off here. So this one is working as a switch and as an amplifier. That's all electronics in 2 shots. Have a nice day and thank you very much. Mabuhay tayong lahat. Bye!